Everyone who's here who needs to be here. Today we have Nathaniel Shaffer and Nate Shaffer, and his presentation is high volume rain events disproportionately increase erosion of waste material from an abandoned coal mine dump. Nathaniel or Nate is with Washington and Jefferson College, and I'm going to give you a little bit of a bio. He is a 2019 biology graduate of Washington and Jefferson College and a 2023 graduate of La Roche University's Masters of Nursing program. Nate is currently employed as a registered nurse at UPMC Mercy Hospital in Pittsburgh, working in the emergency department and orthotrauma burn medical surgeon. Wow. Nate began researching runoff conditions at an abandoned coal mine waste site during his junior year at W&J, under the guidance of Dr. Jason Kilgore. Nate is a lifelong outdoorsman who enjoys hunting, fishing, and hiking the PA wilds. Now, one thing I want to do before I give it to Nate is please fill in your survey for this and any other presentation that you attend, because it's really, really important for us for next year. We need to know everything that you think about this conference. The good, the bad, the ugly, everything. So please let us know. It's going to help us. So without any further ado, I'll give it to Nate.
All right, thank you. Good afternoon. So let's start by talking a little bit about why I'm here, because my background is a bit confusing. I'm lucky enough to be speaking on behalf of a larger group of individuals who have worked on this project. Started around 2017 when Lucy Elkins was looking at vegetation on these sites, and then I stepped in to look at erosion. There was some more revegetation efforts going on through the present. I'm going to be talking about all of that work that I did around 2018, 2019 through now.
Let me see. Okay.
Okay. So these overburden sites that we're studying become an issue because of just the sheer amount of material that's piled up. It's often near roads, places with easy access, which puts it near streams. So this site is an EPA level 3 site, relatively small, with limited regulation and monitoring because of the size. But what we're looking at and what we were trying to determine is there's still a hazard associated even with those small level 3 sites, and do they warrant possibly more monitoring?
Oh, shoot. Let me see. Now try.
Okay, so this specific experimental site is in Marianna, Pennsylvania, managed by Pristine Resources. It's a black dog dump site, which is material of the overburden, and it borders Horn Run, which is outlined here in blue. That's a 10-mile creek tributary, which runs into the Mon later on. And so it just sort of paints the picture of this small site eventually having a larger impact on a much larger watershed.
I think your batteries might be dead again. Oh no, there it went.
So the study objectives of my specific research were to quantify erosion, track it related to precipitation, as well as characterize and measure the slope of this site, and analyze the soil content. We're looking at particulate size and heavy metal content. The erosion occurs at this site because of the limited vegetation. You can see from this overhead picture, it's largely barren and also very steeply sloped. It's a very loose, friable material that just flows away with any amount of precipitation. Our methods of monitoring the erosion involve monitoring the weather and the precipitation at the site. We used a data logging weather station and a tipping bucket rain gauge to monitor closely the exact precipitation that was occurring. We also outlined what we were considering a micro watershed, an area that we could outline on the slope where all of the water was falling to one point and then entering into the stream. So we used erosion pins along this specific area of the slope and also collected the eroded sediment at the bottom as it flowed in order to better quantify the amount of erosion that was occurring. We also looked at various other metrics, including bulk density, infiltration rates of the soil, and then in this picture here, our very rudimentary method of just collecting the soil. I'll talk later on about some of those results, but what we found is that this was a much larger volume than we had anticipated. So to get into some of the results of these studies, Looking at the erosion pins that we set up on this slope, the greatest difference was at the bottom of the slope and on the slope itself, with the loss of material on the slope, and then the largest increase in material on the bottom, which makes sense. This material is obviously eroding downhill. But we found that there was a significant difference in those slopes over the time that we were monitoring. We also looked at rainfall as it correlated to the amount in kilograms of eroded material. This was an area where we certainly need more data points, but you can see that after a certain area or a certain level of rain here, the amount of collected sediment was much greater than we could effectively measure and was disproportionate to any other amount of rainfall. So more data points in the future would hopefully sort of show a better picture of exactly how that trend occurs. But just from our preliminary data, we found that a huge amount of erosion was occurring. And then looking at the bulk density and the infiltration rates of the soil, this is primarily on the top of the slope where some of the revegetation studies I've been talking about occurred. We used a double ring infiltrometer to measure these infiltration rates. They were highly linear, but rather variable amongst the locations that we studied. The correlation between infiltration rate and soil bulk density was also pretty weak. It was only about 0.19, the R value that is. And then looking at the soil, the quality of the soil. So we found that it was high in numerous heavy metals, most notably lead, mercury, and arsenic. It's a very low pH, very acidic material, and is also a very fine particulate. So as this flows into the water, we'll talk about later on, but we found that it was increasing the acidity and also contributing to a lot of silt. So looking at some of the other work that's going on at the site, the revegetation study is looking to reclaim some of this area by stabilizing through revegetation. The plant species that were picked had to withstand poor conditions because, as we talked about just briefly, the soil here is very poor quality. So initially this started as a comparison of little blue stem across another site, a red dog site, this black dog site, and then a reclaimed mine site nearby. This study specifically began looking at revegetation of ground cover grasses and then later on moved to trees. That's the most recent development. It was seeking to determine optimal revegetation conditions as well as the most cost-effective measures for revegetation. There were 4 plants in each site. Data was collected at the beginning and end of each growing season. And initially we were looking at light response through photosynthetic efficiency, CO2 response, chlorophyll content, and then the vegetative and flowering height of the plants, all as measurements of relative plant success. So looking at the photosynthetic efficiency here, specifically at this research site that I've been talking about, the Black Dog site, this is light compensation point, measurement of at which photosynthesis is equal to respiration and most efficient. Efficiency was greater at the end of the season after these plants had been established, which is to be expected, and was greatest at the reclaimed site, which supports the idea of encouraging revegetation at this site and then hopefully getting it to a reclaimed status. Looking at some of the other growth metrics, mean chlorophyll content, and the various soil treatments that are going on that I'll talk about in a bit, we start to get a weak trend towards a greater, towards the greatest outcomes when treated with lime, that we'll talk about in just a moment. And this is just like the beginning of the picture that was being painted as we continue this research. So again, soil treatment seems to have a big impact on plant health in terms of tallest growth and tallest flowering portion of the plant. And this leads into our expanded revegetation study. This included not only little blue stem, but also annual rye, lavender, and an Ernst Seed Company native strip mine mix, which is commercially available specifically for this purpose. We're looking at variables in this study of stem abundance by species and plot, height of the tallest plant by species, plant cover using a modified Dobbenauer method, light response, again, through photosynthetic efficiency and chlorophyll content. I have the results today on the stem abundance and the plant cover to discuss. So just a quick summary of the results. Little blue stem and the seed mix showed the most growth and the greatest potential, and lime, as well as the combination treatments of all variables, resulted in the most plant growth. So looking here at little blue stem and measured abundance, lime and then lime, mycorrhizal treatment, and a straw cover had the greatest growth. I should mention that the straw cover is especially relevant because in areas where this site is in direct sunlight, we measured surface temperatures of upwards of 130 degrees. So some kind of cover was vital to the survival of these plants. Again, lime and the combination treatment in little blue stem saw the greatest growth in percent coverage. The seed mix has similar results, showing greatest results with lime and the mycorrhizae straw combination treatments in terms of both abundance and again in the percent coverage. So this also recently another student began looking at the stream health by conducting a water quality survey. Ongoing study to quantify the impacts of the eroded material on the health of pour and run. There were increased levels of manganese, iron, and aluminum measured downstream of this site compared to upstream, and also decreased macroinvertebrate taxa downstream. The EPT numbers were much lower downstream, and so we know that those are quality indicators of overall stream health. So the big conclusions and takeaways from this presentation. This low-level EPA level 3 site, they're very common throughout this area of Pennsylvania. They're not well regulated or not well monitored because of their size. And so the environmental impacts of those may be poorly studied and may be underestimated as they sort of come together as a large group of these EPA level 3 sites. Also, large precipitation events result in massive quantities of runoff. As I discussed, this eroded material is very acidic, very fine particulate, and has immediate entryway into the waterways and then into our larger waterways. We found that revegetation efforts can be successful. Lime treatments offers the most cost-effective outcomes simply because of the availability of lime and the drastic improvements we saw just by altering the pH. And then if revegetation efforts are attempted, those sites should be monitored to confirm the effects on erosion. So the next steps for this research, improved methods for collecting eroded material so that we can better understand the large rain events or cumulative rain events that are occurring over large periods of rain. Continuing to monitoring rainfall and eroded sediment to better estimate the rates of erosion, better predict the erosion as it occurs with these large rainfall events. There have been ongoing issues of vandalism and theft at the site, so it's been difficult to monitor the rain, monitor precipitation as it occurs without like our rain buckets. There are continued revegetation studies that are ongoing to collect and analyze additional plant health variables and expand the study, as well as tree planting that just occurred in the spring or in November 2022, where 10 saplings were planted as part of an anticipated 10-year study. Various native species, 5 control and 5 received as lime and shredded mulch as a treatment. The initial tree heights were measured to determine their growth, and then we'll be continuing to monitor for the next 10 years as an additional revegetation effort. And so, like I said in the beginning, I just want to acknowledge that numerous other people have helped to conduct this research over the years. W&J has obviously played a large role. Pristine Resources has allowed us access to the site, and numerous other students have taken part. And we'll open up to questions.
Anybody have any questions for Nate? I do. The decline in EPT taxa downstream of that site, do you think it's more due to sedimentation, or is there a non-lethal aspect of the magnesium and aluminum and iron that's affecting the populations? What's your take on that?
I think it would be probably the sedimentation. The silt is I think would be playing a big role, and then the pH as well. The acidity of the runoff coming into the stream is pretty great.
Any other questions for Nate? Okay, thank you so much, Nate.